let's take some of the challenges which we've had across UK and France. This was presented in Munich last year, and gives you a selection of the European challenges that we found. So, so this was one presented by Infineon. Okay, Infineon in the UK. Infineon, a German company, have offices mainly in Munich, but UK and in Bangalore as well. And they set the challenge of how to make better use of their simulation cycles. We all spend a lot of money on our simulation cycles. And their biggest challenge is how do we know that random generation actually adds value after a certain amount of time. We all have our coverage models, and we all judge our random generation through exercise of those coverage models. But they get the sense, and I think a lot of companies get the sense, that after a certain amount of time, your simulation cycles are doing the same thing and not adding much value. And how do you actually measure that you are still adding value through your randomness? And verification closure takes a long time. I guess we can all get to 80, 85, 90% fairly quickly, but the last 10% is a lot of effort across the industry. So how do you actually make best use of the simulation cycles to get you 100%? Using directed, there is a bit of a move within the industry at the moment for graph-based techniques. You'll be listening to Brecker later, but I know some of our other vendors, Mentor, for example, have a graph-based solution as well. But they asked, they've looked at those tools and they've asked if they can really hit deep corner cases. Maybe Brecker and Mentor can talk to that. And they asked if there's other ways, random mutation, machine learning techniques. But the theme from Infineon, and I think that's a common question, is, am I making the best use of my simulation cycles? Am I getting value for money from my simulation farm? NVIDIA talked about performance verification. So they see good advances in functional verification. We heard this morning about UVM, and personally, I think UVM is a huge step for our industry. The fact now that all the major EDA vendors are converging on UVM and making it into a real industry standard, and a de facto one as well that everybody's using. But they didn't see an industry solution really for performance verification, and their sense is a lot of companies cut their own way of doing this. So they look at something like coverage for functional verification. We have coverage, we have languages for defining coverage and measuring coverage, but there's no real industry standard for defining and measuring performance. Okay, so that was their main challenge. How do we find a language? How do we find a way of speaking about and measuring performance verification? The next one was Broadcom. So their main challenge was how we moved from IP level verification up to chip level verification, and that specifically SoC. We heard this morning from Synopsys that SoC, everything's starting to look like an SoC, and I know Javi Foster of Mentor Graphics does a lot of research into this, and the percentages that Javi presents bears this out, that most chips now look like SoCs. And although we're very, very, very good at IP verification now and using constrained random verification to do IP verification, the sense from Broadcom is that it's a chip now where a lot of the problems are. How you keep up with the rate at which designers can turn out these chips. Designers now have the advantage of big blocks of IP and integrating these big blocks of design IP onto a chip relatively straightforwardly, but the verification remains a huge challenge for those chips. And also that at the top level, at the chip level, they're starting to see more challenges creep in. So, for example, power verification, which you can only really do at the chip level using CPF or UPF. You can only wait and really until you get to chip level. Performance verification, going back to what NVIDIA said, again, a lot of the performance verification can only be done at chip level. Wilson have the challenge of traceability. So they want to be able to make sure that every single customer or product requirement has actually been verified. And we're starting to see a lot of more customers ask for this now. How do they demonstrate that all their customer requirements have been properly verified? Especially over really complex designs, lots of chips with a lot of IP revisions, configurability. So how, as you make your way through verification, you're not just focusing on code coverage, you're not just focusing on functional coverage and running all your pseudo-random and directed tests, but you're actually making sure that you've actually verified and signed off on every single product and customer requirement. For some companies, that's actually mandated for a standard. So, for example, maybe people in the audience working on automotive, where you're mandated for ISO 26262 to do this for your safety requirements. But I think to make sure that they're meeting what their customer wants. Dialog are a mixed signal company, and we've already heard from NXP on this topic as well. As analog becomes more and more part of our chips, and a lot of the analog design moves onto the chip, we're seeing a lot more integration of analog and digital. And Dialog's latest go is simple problems. A lot of our clients, it's the interface between the digital and the analog, and trying to get a good understanding, a common understanding between the analog designers and digital designers about the interface, and then being able to verify across that interface and having suitable models which allow you to run your simulation at suitable speed. They have the sense that in the past, analog verification techniques have been slightly ad hoc. And how can you move the digital techniques which we developed for the digital verification over to the analog world? This was an ARM one that was presented by Brian Dickman, who runs the verification worldwide for ARM. And bug avoidance. So I mentioned this morning after the synopsis presentation about bug avoidance. How do you help designers avoid putting bugs in their designs in the first place? How can you actually make it easier for designers to have a way to make bug-free designs? So if there were less bugs in the designs, there'd be less verification to do and less debug to do. And ARM are trying to find ways to enable their designers to create bug-free designs or designs with less bugs in. In my time in the industry, certainly over the last 10, 15 years, there's been a huge amount of innovation in the way we do our verification. So verification engineers are now used to innovation, new ideas coming in, looking at new techniques, looking at different tools all the time. A lot of people here today to find out new techniques and tools. But there's not been that revolution and that level of innovation in the design community. I still look at a lot of designers using an editor to write RTL. And the level of innovation is low. And I think ARM feel that there needs to be we need to focus some of our efforts on the design side to try and make it easier for them to create designs which have less bugs in. This is from ST. Again, this has been hinted at by Synopsys this morning about the amount of data we produce now. We are now very, very good at producing data. We run long simulations. We have huge coverage models. We generate lots and lots and lots of data. But you have to turn data into information. So it's not just useful to have terabytes of data. Terabytes of data isn't useful unless it actually provides you with good metrics, good information, which allows you to make decisions. So the challenge for ST was how can you actually turn all that data into information which allows you to make a decision. SD Ericsson, their main challenge was how to outsource their verification effectively. They see outsourcing as a means to an end. There's something they have to do. Within their company, they're never going to have enough capacity. Also, verification can create huge resource demands at certain points in their project. So they don't always need that resource. So how can they effectively outsource their verification and know that a good job's been done when that's been outsourced? Finally, Texas Instruments, hardware, software co-verification. So when I first started in the industry, it was enough just to make silicon and give them to your customers, and they would then worry about the software. But our industry now is at the point where you have to deliver software with your hardware. And the question is, how do you actually do effective hardware-software co-verification? We can't just focus on the hardware anymore. We have to focus on the hardware-software co-verification. And that's it. Okay. So they're the European challenges. So we've been doing this conference in Europe now for two years. This is our third year of running the conference. So there are a number of challenges, probably about 40 or 50 challenges that have been presented within Europe over that time, and that's just a selection of them.